In our previous video, we discussed the mean as a measure of central tendency. In this video, we'll discuss the median and the mode. Whereas the mean is the mathematical balancing point for a set of data, the median is the middle score or the 50th percentile rank. It's the point where half of the scores are above the median and half the scores are below the median. Now, let's say I have 5 scores, 4, 10, 13, 3, and 2, and I want to find the median. To find the median, you simply order the scores from lowest to highest, or highest to lowest, and find whatever value falls right in the middle. That's your median. In this case, we have an odd number of scores, 5, so it's easy to see. Here it's the third score where there are 2 scores above it and 2 below it. It doesn't matter what any of the other scores are, whether some are close together or some are far apart. The median is the middle score. Now, if there are an even number of scores, you calculate the median as the halfway point or average between whatever 2 scores are in the middle. If we modify the data a bit so that we have an even number of scores, our 2 middle scores in order are 4 and 6. So the median is halfway between them, or the mean of 4 and 6, which is 5. Because the median is simply the middle score, it's not influenced by extreme scores. The mean gets pulled towards an extreme score, but not the median. Consequently, in situations where the data are stretched or skewed in one direction, the median may give a better sense of the typical score than does the mean. A third measure of central tendency is the mode, or most common value or score. It's typically used with nominal or categorical data, such as state of residency or race ethnicity, rather than ordinal or interval or ratio data, such as scores on a test or hours worked or ratings on scales. That said, it's worth noting that with nominal data, you can't even calculate the mean or median, so the mode is it. Now, here's an example of nominal data, race ethnicity in a sample. In it, we see that the mode was white non-Hispanic. Also notice that we have a single mode, but if you recall from our discussion on the shape of distributions, you can have bimodal distributions as well. Remember, people either loved or hated the movie The Last Jedi. Now, even though the mode is generally used with categorical or nominal data, it can be reported with ordinal, interval, or ratio data. Generally when there's a limited number of values, like number of children in a family. In those cases, you can also imagine that the mode, like the median, isn't influenced by extreme scores. Now, when we put this all together, there are different general types of distributions where the mean, median, and mode follow certain patterns. For example, later we'll learn about the normal distribution, in which scores cluster around the middle and are evenly distributed on both sides. In this type of distribution, the mean, median, and mode are all the same value. In contrast, when data are positively skewed, the mode will be the lowest of the 3, followed by the median, with the mean getting pulled out to larger values. The reverse happens with a negatively skewed distribution. In this case, the mode has the highest values of the 3, with the median lower than the mode and the mean the lowest, getting pulled out to small or negative values. So that's the mean, median, and mode. Now the important question, which one or ones should you use? Well, it depends. For example, if you have categorical data, you don't have much of a choice. The mode is the only one of the 3 that's applicable for categorical data. it's also less sensitive to extreme scores. The median is also less sensitive to extreme scores, and given it reflects a case at the midpoint of the data, or the 50th percentile, it can be informative in describing the typical score when data are skewed, particularly if the data are highly skewed. The mean has several substantive advantages to both of these. It has the strongest sampling stability. If you took several samples from the same population and calculated the mean, median, and mode each time, the mean will typically fluctuate the least from sample to sample. The mean is also what's known as mathematically tractable, meaning that there are more things you can do with it, and it can be used in more ways mathematically than the median or mode. We will definitely use those additional powerful qualities of the mean, things like the sum of squares, over and over again in statistics. However, of the three, the mean is also most likely to be influenced by extreme scores. So, which one is right? Let me answer that with a personal story. A relative of mine used to work at Boeing, and years ago it seemed they would go on strike every few years. I remember one summer I was visiting, and he came home from work furious. "We're going to go on strike. We can't trust management. They're lying to us." So I asked him, what's up? And he said, "The union has done the math. They very clearly can show that the typical employee is getting paid," I don't remember the exact number, it's not important, but we'll say $30,000 a year. Management comes back and they're telling us that the average salary is $40,000 a year. Clearly they're lying to us. We can't trust them. We got to go on strike. So I dug into this with him a little bit more, and what do you think I found? Well, from the union's perspective, what were they reporting? They were reporting the median salary, which makes complete sense for the union, because from their perspective, yeah, there's a few people getting these outrageous, really high salaries that are skewing the distribution up. So they want to report the median as the typical salary. Makes complete sense, completely honest. Best way for them to look at it, given their perspective. But what about management? For management, the median isn't a useful number. When it comes to paying the salaries, it's the average salary that matters. The average salary is the total salaries divided by the number of people. So how much money do you need to have in the bank every month to pay those paychecks? Well, it'll be based on the total salaries divided by the number of people. You need to take whatever the number of people you have, multiply it by the average. That's how much you need to have in the bank every month, or else paychecks are going to bounce. The only number that makes sense, if you're the accountant, CFO for Boeing, is the average salary. The average salary tells them how much to have in the bank, or checks bounce. So of course, from the management's perspective, the median isn't important. It's the average salary that they need to worry about. So you've got both groups reporting different measures of central tendency. And both measures of central tendency make complete sense from their perspective. It's not even necessarily that they're trying to distort or manipulate or cheat the other side. From their perspective, if you're the union, the median salary is the important number. If from your perspective, if you're management, the average salary is the only one that really counts to keep people's checks from bouncing. Now, that's really kind of cool that the perspective influences what's the right choice. And we'll see in statistics, that's kind of one of the exciting, cool things about it, is that sometimes there is no one single best answer. It depends. It depends on your perspective. It depends on what you are going to do with the data or what you need from the data. So on that note, let's wrap up this conversation about measures of central tendency. Okay? Pretty exciting, huh? Take care. Bye-bye.